Welcome back to a new tutorial about specific heat capacity. Let's see together what is a specific heat capacity of an object. A car subjected to a strong sunlight can become very hot. A concrete block of an equal mass to that of the car should not become as hot because metal heats up more easily than concrete. But why is that? Investigations show that when a substance is heated, its temperature rise depends on three factors. 1. The amount of energy supplied to it, for example, heat or electric current. 2. The mass of the substance, because if we want to calculate the specific heat capacity of any substance, we should know its mass. And 3. What the substance is. It could be liquid, like water and oil, or it could be solid, like aluminium and lead. Here, we heated up two different amounts of water. The first amount of water is equals to 0.1 kilograms, and the second amount of water is equals to 0.2 kilograms. We found that heating 0.1 kilograms by 4 degrees Celsius required an energy transfer of 1600 joules. But heating 0.2 kilograms of water, meaning the double quantity, at 4 degrees Celsius as well, required an energy transfer of 3200 joules. You can notice that it's double the amount of the first amount of energy transfer. If we multiply this value by 10, we obtain that heating 1 kilograms of water by 4 degrees Celsius required an energy transfer of 16,000 joules. And if we divide this value by 4, we obtain the amount of energy needed to raise the temperature of 1 kilograms of water by 1 degree Celsius. It is equals to 4,000 joules. More accurate measurements would give 4,200 joules per kilograms degrees Celsius for water. This is the specific heat capacity. So what is the specific heat capacity of an object? Well, it's the energy needed to raise the temperature of 1 kilograms of the substance by 1 degrees Celsius.